All right, every single time you go online, there's this incredible, invisible world of machinery that's making everything just work. Today, we're going to peek behind the curtain at one of the most important pieces of that machine, the transport layer. Think of it like the internet's hidden post office, the thing that manages the absolute flood of data zipping in and out of your computer.
I mean, really think about it. You've got one internet connection coming into your house, just one pipe. But somehow, you can be streaming a movie, someone else is on a video call, and emails are still coming through, all at the same time, and nothing gets mixed up. How on earth is that possible? Well, that exact puzzle is what the transport layer was designed to solve.
To really wrap our heads around this, we're not going to start with code or packets. We're going to start with a simple story, a tale of two houses packed with cousins who just love to write letters to each other. So, just picture it. You've got one house on the East Coast, another on the West. Each one has 12 cousins living in it, and every single week, every cousin writes a letter to every single cousin in the other house. If you do the math, that's 144 letters flying in each direction every single week. That's a mountain of mail, a real logistical nightmare. Okay, so here's where our little story gets really powerful. It maps perfectly to how the internet actually works. The cousins, those are your apps, Netflix, your email client, that video game. The two houses, those are the computers, right? Your laptop and, say, a server somewhere. The postal service carrying all those letters between the houses? In the real world, that's called the network layer. And Anne and Bill, the two people inside each house sorting all that mail, that is our hero of the day, the transport layer.
Let's really zoom in on those mail sorters, Anne and Bill. Their job is absolutely critical. See, the Postal Service, it only cares about one thing, getting a letter to the right house. But Anne and Bill, their job is to make sure each letter gets to the right cousin inside that house. That's a huge difference.
And this idea brings us to a really cool concept called logical communication. The Postal Service gives you a connection from house to house, but from a cousin's point of view, it feels like Anne and Bill have created a private direct line just for them. It's a special mail service connecting one specific cousin to another, even though they're on opposite sides of the country. All the messy details in the middle, they're handled.
So, the whole process is pretty straightforward. A cousin writes a letter that's just like your application creating a message, and comes by and collects it along with all the other letters. That's the transport layer, gathering up data from all your running programs. Then she bundles it all together and just hands it off to the mail carrier. And this shows something really important. Anne and Bill do all their work inside their own house, or in tech terms, inside their end system. Once that mail truck drives away, they have zero control. So, our family story is going great, but now there's a plot twist. What happens when our super organized, super reliable mail sorters, Anne and Bill, decide to take a much-needed vacation? Well, let's just say their replacements have a different work ethic. Yep, as the source material puts it, in step Susan and Harvey to take over the mail duties. And the family is about to find out that not all mail sorting services are created equal, not by a long shot. Anne and Bill's service is pristine, it's reliable, it's organized, they are meticulous. They would never, ever lose a letter. Susan Harvey, not so much. They're a little bit lazy. They don't pick up the mail every day, and, sometimes a letter just gets lost. Maybe it falls behind the couch. They just provide a fundamentally different and way less reliable service. Okay, it's time for the big reveal. This whole story about a reliable A-team, Anne and Bill, versus the kind of flaky B-team, Susan and Harvey, it's not just a cute story. It's actually the perfect analogy for the two main ways the entire internet sends and receives data.
But first, you need to understand something huge. That postal service of the internet we talked about, it's called the Internet Protocol, or IP. And here's the crazy part. By itself, IP is completely unreliable. It's a best effort service, which is a nice way of saying it makes zero guarantees. It doesn't promise your data will get there, or even that it will arrive in the right order. It just tries its best. And that is why the job of our mail sorters is so unbelievably important. And here they are, Anne and Bill, our reliable, organized, never-miss-a-beat mail sorters. That's TCP, or the Transmission Control Protocol. And Susan and Harvey, our fast, no-frills, but sometimes loses a letter pair. That's UDP, the User Datagram Protocol. TCP literally adds a whole layer of reliability on top of that shaky IP postal service, while UDP pretty much just passes the mail along and hopes for the best.
So how does TCP pull off this miracle?
Well, it's got a whole bag of tricks. It puts sequence numbers on everything to make sure messages are put back in the right order. It sends back little acknowledgments to confirm something arrives safely. It even has timers to resend anything that gets lost along the way. It's basically Anne with a super detailed checklist for every single letter that goes out the door.
And UDP, what does it do? Well, the bare minimum. It makes sure the data gets from the right app on one computer to the right app on the other. And it does a quick little error check. And that's it. No confirmations, no sequence numbers, no resending lost stuff. It is the definition of a fire and forget protocol.
So you see, the big takeaway here is that there's no single best protocol. It all comes down to what your application actually needs. When you're sending an email, you absolutely need every single byte to arrive perfectly. You need Anne and Bill, you need TCP. But what if you're on a live video call? You care way more about speed than perfection. A single drop pixel is no big deal, but a 5-second delay is a disaster. For that, you want Susan and Harvey. You want UDP.
And that really leaves us with the central question of the entire transport layer. If TCP is the reliable one, the one that guarantees delivery, why in the world would a developer ever choose the unreliable option? Well, as we've just seen, it all boils down to this fundamental trade-off between getting it perfect and getting it fast. And making that choice is what allows our modern internet to do all the amazing things it does. Thanks so much for tuning in.